We're at the University of New Hampshire Interoperability Lab once again, and once again we're going to be looking at a CloudCO demo, and this year, Craig Thomas, you're actually with us, and why don't you kind of set the stage for what we'll be seeing here?
Yeah, so I'm really glad to be here at UNHIOL, one of our approved partners and OB Lab partners as well. We're here doing the setup for our annual CloudCO demo. It's an exciting time for us because it brings in so much variant work areas of our work, from everything inside the home and bus, across the ATA and the FAN network, and especially in the SDN NFV. So with CloudCO, what we're demonstrating here really is how does a network that has been historically driven by SDN for network efficiency reasons, separating the control and the user plane to make it more agile, and now moving into something that is basically enabling new service delivery across the platform, disaggregating, virtualizing services, network orchestration, BNGs, OLTs, ONTs, an end-to-end ecosystem driven by a CloudCO SDN NFV network. And it's exciting for us. It's driven by the service provider's demands. And then this demo brings in, this year, 10 separate different vendors showing that interoperability and how to develop the operator's CloudCO.
So what is the CloudCO and the drivers and the importance to the industry?
CloudCO is basically about bringing the innovations that happened in the IT, enterprise and data center world into the central office, into the broadband access domain. And so those innovations really shook up that industry at the time, and the innovations then that we talk about are, for instance, software-defined networking, cloudification and virtualization, CI/CD, agile way of working, microservices-based architectures, and more recently the breakthrough of AI/ML. All these innovations are now brought into the broadband access networking domain, and for a good reason, because they provide quite some advantages. One of the first advantage is it does deliver scalability. The second is that it allows to bring together hardware and software components of different vendors. It can also remove the siloed way of working that operators used until recently. And perhaps most important, all these new innovations and capabilities should make life much more easier for operators, because now this, in the end, it will result in network automation, which will bring down the total cost of operating the network. Fundamental to the success of CloudCO are in fact two things. One thing is in fact delivery of standards for defining interfaces, for defining architectures, for defining data models. This really allows multi-vendor interoperability, and that's what standards are all about. And second is that operators also want some kind of proof that this concept is actually working for them. And so what BBF did is that they create what we call OB projects, which are in fact open source projects, where actual implementations are made by a community of vendors, which are among others also then demoed in the CloudCO demo.
So what's being shown in this year's demo, and what are the use cases?
We want to highlight two areas, network domains in the CloudCO demo, access and IP edge/IP transport. First, access. So access has always been a strongholder for the CloudCO demo, and this year is not different. So we have OLTs from 6 different vendors, OLTs and ONTs, and they're all managed by an access management platform and based on the TR413 certification, which defines the netconf protocol and also the young data models, and this is all described in the TR413 spec. So in the access domain, we demonstrate flawless high-speed internet access setup among all those OLTs. So the demo also includes, of course, the IP edge domain. And so this year we have 3 BNG vendors participating with their BNG to the Access CloudCO demo. So 2 of those BNGs are following the CUPS approach, where we have a physical split up between the control plane and the user plane. On top of that, we also show the use cases related to 1 working from home, 2 secured high-speed internet access, and 3 also traffic steering.
So is there anything new compared to previous demos?
This year, as mentioned before, we also have the use case related to the security. So basically we have two use cases there. So one is where you have an existing high-speed internet access service, but then subscriber wants to activate security on top of that service and can do so by a subscriber portal. And the other sub case in that environment is that you have a secured working from home session. And all of these two use cases are in fact enabled by means of this secure service edge gateway as well as a secure service edge controller that work together and which allow to enable dynamically the security policies. So these use cases are examples of new revenue generating services that ISPs can bring to their customers. So this year we also demonstrate traffic steering, and we did that also last year. The difference is that this year we have a dedicated traffic steering function that is part of the setup, and we make use of dedicated VXLAN tunnels to lead the traffic to and from the BNG user planes. We have a probe residing in the network that constantly measures the delay on the network paths between two of those BNG user planes, and based on that measurement the probe will drive the traffic steering function to steer the traffic to that BNG user plane which has the best delay performance. So related to the access domain, the new aspect this year is that we have in fact two different access controllers. Both are controlling OLTs based on the TR413 interface specification of BBF, so which is testimony to the popularity and the acceptance of that interface among the ISP service providers. We also have several OLTs of which the OMCI function is extracted from that OLT and moved towards the cloud and hence hosted as the virtual OMCI function. This year we also want to emphasize the openness of the access management platforms. For instance, in the case of Nokia, the Altiplano solution, there it has an open framework which allows to host third-party applications. And so the application that is hosted on Altiplano in this demo is the delay measurement analyzer from company Altis that takes as input the delay measurements of the probes, and then used on this analysis steers the traffic steering function. With respect to the other access platform, which is the SEBA from Netsia, so the SEBA platform also demonstrates its openness towards the southbound because it's capable of managing both OLTs which are compliant to the BBF TR413 interface, but also white box OLTs that support the ONF access management interface.
So who's participating in this year's demo?
Well, we have a mixture of different vendors. So we have, on one hand, the access management platform providers, which are Netsia and Nokia. And we also have 6 OLT/ONT vendors. So these are Altis Labs, BSDN, Capgemini, Netsia, Nokia, and Redisys. At the IP side, we have Zyxel demonstrating their white box BNG hardware, which is equipped with the network operating system from Capgemini, as well as distributed BNG solutions from BSDN and from Ciena. And next to that, Ciena also provides, with its partner, Security Service Edge Gateway and Gateway Controller. BSDN will provide the traffic steering function, which is driven by the QED probes from Altis.
So we're here today with Lincoln Lavoie of the University of New Hampshire Interoperability Labs and also the technical chair of the Broadband Forum. Lincoln, thank you for hosting us once again.
Hey, great, Ken. Thank you for coming. And we're happy to be hosting and setting up and organizing the NetworkX demo for Broadband Forum that will be displayed in Paris coming up in October. So we're going to take you through the demo, get a little bit of a deep dive in a minute. We have been working with 10 vendors to integrate all of their products and their software into a disaggregated software-driven network based on CloudCO, along with open source software from ONF SEBA, as well as the Broadband Forum's OB or Open Broadband BAA systems as well.
So something that's new this year is this OMCI, and that's going to be part of this year's demo. So why don't you explain a little bit about that?
So virtual OMCI is really the next step along disaggregating in traditional OLT, breaking out what would have been embedded into the hardware and running on the processors in that system in the access node into a more cloud-native environment. This year's demo is building on top of the work the forum has just completed with the virtual OMCI Plugfest that's run over the summer with a number of the vendors that are actually here in the demo as well, where we've actually moved the OMCI stack, and in this case we're actually going to be working with the open source stack from the Broadband Forum's OBBAA software. That's running up in the cloud, and there are multiple OLTs now in the demo that you'll be able to see here where they actually are using that OMCI stack running in the cloud there to move and manage the ONUs that are connected to them. And then we actually have a good example there where we've brought in the interoperability case because we have ONUs from multiple vendors connected to differing OLTs connected to that OMCI stack. And so it really is delivering on the promise of that disaggregation software-driven network, since we've actually been able to do choice and flexibility in the software layers that are enabled through the virtual OMCI.
So what are some of the other key elements to the demo?
Yeah, so this year with the demo, we've got traffic steering, which is based on top of the Broadband Forum's 459, which is the disaggregated BNG, as well as the 474 work, which is how traffic steering actually works. That's actually being triggered by our QED, which is measuring performance of the broadband links and looking for congestion or other issues in the network. And then obviously with the CloudCO and the programmable network, as soon as you see those issues occur, the controllers then are able to reprogram the network, steer the traffic between the various BNGs and such. So that's one layer of the demo. Obviously, we just talked about VOMCI a second ago. And then we actually build on to secure internet and work from home scenarios, again, being enabled through the programmability of the network, where you're able to have the end subscriber toggle on a service. The network kind of reprograms itself to enable the service, whether it's running traffic through a security system in the cloud or actually spinning up an entire tunneled session to enable work from home, where an end consumer or a company, an enterprise that would be working and providing that service is able to manage that traffic directly, so they can enforce all of their company policies on that kind of blip of home network that's dedicated to that work from home case.
Tell us a little bit about the zero-touch provisioning and how that works in the context of this year's demo.
Sure. So zero-touch provisioning is enabling essentially service turn-up of the subscriber. What would be historically the OSS BSS system, subscriber orders service, that goes into kind of an ordering portal, and then the network automations start acting upon that. So within the context of the Broadband Forum's CloudCO, there's domain orchestrators and domain controllers that are basically driving activity down into the network, provisioning the systems, enabling the flows, the subscriber traffic, ultimately preparing the network, waiting for that attachment event where they actually see the subscriber plug into the network, and then the service provisioning completes and automatically finishes the attachment of that device to the network. And you have to remember, in the context of the demo, this seems simple because the device is right here. But in the context of a large service provider network, that device might be on neighborhood A, neighborhood B, might appear on very differing OLTs and stuff like that. If you were thinking about this in a non-automated fashion, the operator would have to go out, provision exactly where that service is for that specific device so that that device was attached into network A, network B within their domain. Whereas with the zero touch, we're really looking at automation, right? So it's essentially tell the network to get ready for this device to attach. The network gets ready and is kind of watching always for device attachments and stuff. When it actually does see that attachment, it goes up, queries where that actually is, links it to the subscriber records, and then provisions itself to provide the services that subscriber ordered directly from the network.
So within the demo, are there other ways that the network functions are being disaggregated or moved into the cloud?
Much like the eOMCI moving to VOMCI or virtualized OMCI, there's also other components within the OLTs that historically would have been built into that hardware or the software running directly on there that are also being migrated into the cloud. So we're also showing a case of DHCP and DHCP relay, where that would historically have been on the OLT, been provisioned as part of that one kind of box. It's responsible for intercepting and injecting records into the DHCP packets as they're moving through the network. That don't really need to worry about what it's doing there. But the important part is we're actually moving that functional component, and that's becoming software also running in the cloud. And then what we're actually showing here as well is we're scaling that component horizontally. So as it sees the number of subscribers or the subscriber load increase, it automatically spins up additional instances of itself within the cloud so that it's able to meet that growing demand. So the network and the utilization of those cloud resources essentially grows as the subscriber base grows, and it can do the opposite as well. It can shrink as necessary as well, so you're not needlessly kind of spending CPU cycles or running systems in the cloud that might not be being used right at that moment in time.
And that compute power can actually be distributed as well, right?
Exactly. So what will be on the show floor is only a slice of the actual management and control planes and stuff like that. So when we go to Paris, we'll be taking some of that equipment with us, and some of those virtual functions will actually be remaining here in the lab running in our on-premises cloud as well. So it really is showing that separation of the control plane, management plane, from the user plane forwarding, where the user plane forwarding is going with the OLTs, all the equipment that'll be on the show floor. But that management control plane is going to stay here right in New Hampshire in the lab running during the demo.
How important is the Broadband Forum and the Broadband Forum's CloudCO to Nokia as far as bringing your solution to market?
CloudCO is very important. Ultimately, CloudCO will bring and it will enable network automation. And that's fundamental to operators because this will help them drive down the operating costs to run their networks. A key merit of CloudCO is the definition of standards defining interfaces, data models, architectures for the fixed networking domain. So today, building networks is no longer done in a closed, static environment using proprietary interfaces. This is something that belongs to the past. So standards interfaces, data models, and architectures are the only way to run effectively a network across different technologies, different domains, which has different vendor solutions in place. So operators really demand compliancy to standards in their RFPs and RFIs. And Nokia has always been active, also in Broadband Forum, to realize those standards based on consensus within the standard community.
Nokia are heavily involved in the demo, so given that it's a multi-vendor interoperability and Nokia brings so many elements, why is this important to Nokia to be part of this process?
This year we want to emphasize the openness of the Altiplano access management platform. We want to keep on demonstrating our solutions, so the Nokia hardware and software, together with the components and solutions from other vendors, because that's exactly the reality of today in our customers' networks. So how do we demonstrate this openness? So first, the access management solution of Nokia is able to manage different OLTs from different vendors based on the TR413 specification. And so we also show that we not only manage and control the OLTs, so the physical hardware, but we also manage the virtualized function. So take as an example the virtual OMCI. So we know that the OLT interoperability is still a pain point on the management layer. The OMCI specification has many options. It means that an interpretation of that OMCI specification can quickly differ between an OLT vendor and an ONT vendor. The way this can be resolved is by having the OMCI extracted from the OLT hardware. So what basically happens then is that we throw a virtualized OMCI function into the cloud. This allows then a much more rapid deployment of new services on top of those ONTs that are used in the network in combination with the VMCI. Last but not least, Altiplano is also an open framework that allows to develop different use cases, to write as an operator your own code, or also to integrate third-party applications that are related to the network management. This is all facilitated by providing a software development kit that we provide towards the software vendors. By opening up the Altiplano, so we are kind of giving a flexibility that operators are seeking in order to automate their network. We definitely think that this openness is something that providers and ISPs will appreciate. For instance, also in this demo, in this CloudCO demo, we demonstrate that by hosting this QED analyzer from a company Altsys into Altiplano, where they made use of this application SDK.
So tell us about how Nokia has addressed the rapid evolution in the access network domain, what changes we can expect in the near term and the long term, and what does the CloudCO approach bring to Nokia's approach?
For us as Nokia, it was a big step to move from the days classic EMS system where you configure the access equipment through CLI towards what we have today, so this open and flexible access management platform called Altiplano. So about a decade ago, it was rapidly understood that NetConf was in fact the way forward to do device management. That was supported by standards organizations like BBF and ITF. So the idea of having a persistent management agent in the cloud was also a fundamental step forward, and this one also enabled a very efficient way of operating the network and delivering a kind of zero-touch way of doing so. But now things get even more exciting, because with the CloudCO concept, you can have access to all kinds of data in a uniform and centralized way. And so we are talking about, in fact, telemetry data, which is captured from all the devices across different domains, across different devices stemming from different vendors. Then this data will ultimately be fed into AI ML algorithms. And this will allow operators to better understand, to control, and also to run in an automated way their networks. So think about early anomaly detection, alarm pattern correlation, proactive trend prediction, what-if analysis based on digital twins, capacity management. So it will offer a range of new use cases, and so we're only at the start of this journey.
Why don't you tell us about why Ciena chose to participate in the cloud, in the Broadband Cloud CO demo this year?
If you think about Ciena, you probably think about our optical heritage, right? We've been in the optical business for many decades now, right? And I think we're a global leader in that space, and our products have been deployed globally in major carriers for all kinds of applications, undersea applications, data center interconnect applications, long-haul applications. Over the past several years, though, we've kind of moved up the stack, so to speak, into switching and routing. So in the last 7 or 8 years, we built an entire portfolio of switching and routing platforms, and we've got that optical heritage. The other thing we've done is kind of started to integrate optical and IP, so bringing IP deeper into the network. But we saw where the funding was going, right? The kind of core of the network and the middle mile starting to get unlocked with gray optics and coherent optics now. And now we're seeing a convergence of physical plant build. And why is there physical plant build? Because there's a lot of funding coming in, government funding. We want to bring the internet to everyone, right? And so what's the infrastructure you're going to build? If you're going to do that today, it's going to be all fiber. So we got a fiber heritage. We've certainly got a long history with carriers. And now we see the last piece of the equation is unlocking the access. And we've been talking about kind of universal aggregation for many, many years, right? And we're really to the point where you've got a convergence of money, which drives everything. You've got physical, fiber infrastructure going in. And now you've got these 10 gig access technologies, and specifically passive optics, that really enable us to unlock the access network and to try to provide truly universal aggregation. So not just separate networks for business and residential, but converged networks for residential applications, for business applications, with 5G for kind of mobile front haul and back haul applications. So we saw this convergence. We went out into the market and leveraging kind of our philosophy of being open, which is critical, modular, which has always been a big play for us, particularly with our transport optics going into our switching and routing platforms, but also scalable, right? And we went out and we acquired 2 component pieces, basically passive optical network components with our XGS-PON pluggable optics. But we also understood the power of software. Now, we've got a lot of software with our Blue Planet orchestration layer, our management and control EMS, but we wanted something in kind of the subscriber management space, so we acquired subscriber management capabilities, and that really handles just the network side of the equation. Of course, we know that when we talk about subscriber management, that's really a whole stack from OSS, BSS to components in the home to deliver services. So really what brought us here is that history, the convergence of the technologies and the money. More importantly, we knew as new players in this new domain that it was incumbent on us to become partners with BBF. And we think that our open, modular, scalable philosophy melds quite perfectly with the OpenCO demonstration.
So tell us a little bit about your secure services demonstration that you'll be showing here.
we wanted to do something different. We do have our own access equipment, but there are many, competent vendors that are a part of this demonstration. We wanted to do something a little bit different that highlighted our disaggregated virtual BNG function. That disaggregation helps in a couple of ways. One, it helps us scale horizontally in the user plane, right? And we can also actually distribute where your peering points are in the network. If you look at more of a traditional BNG, you're aggregating not just control traffic, but all the user plane traffic through a single box, which is more prone to failure. With software disaggregation, you get better resiliency, you get better scalability both in the user and control planes. But why the security application? Well, we wanted some way to demonstrate a very fundamentally important part of a disaggregated BNG, and that is getting IP presence deeper to the access edge, right? And to demonstrate that, we wanted to demonstrate security. Why security? One, we do have an offering, but more importantly than that is to demonstrate that we can bring security into the carrier network before subscriber traffic hits the internet, and we can do that without having to have a specific device in the home. The specific applications for security we'll be talking about is really related to a secure internet access, so think about overlaying that kind of capability, but also a clientless work from home scenario. So leveraging the carrier residential gateway to really create a second network in the home that when you connect to that network, you're virtually on your business network. Again, we're just using this as an example. The most important message in all this is getting that IP presence where it needs to be. Other applications, whether it's virtual reality where latency becomes highly critical, you don't want to carry that traffic back to the core when you can do local switching. If you're doing smart vehicles where you need very low latency, or let's say you're bringing in over-the-top multimedia applications, live stream, for instance, is a perfect example where you certainly don't want to bring 100,000 copies of the Super Bowl into your network over the top. So to make bandwidth utilization at your peering edge more optimal, you want to bring that in with one stream and then replicate it where it makes sense deep in the access edge. So again, just using this one application, but the bigger message is about bringing IP deeper into the access edge.
And before you describe how that is going to work, why don't you talk a little bit about, because I'm just kind of curious, the policy aspects of this, the fact that it sounds like from an operator's standpoint, it can be a much more dynamic environment in terms of introducing new services and so forth. Is that part of the value?
Yeah, that's a very important part of the value. And you've heard this term service chaining, right, for many, many years. So what we're doing is really demonstrating a service chaining between subscriber management functions where the policies for the quality of service aspects of the service would be applied there, and then bringing in part of a secure access service edge, really a next generation gateway or firewall function into the access edge, and the policies for security being applied there. And in our demonstration, I know we'll talk a little bit more detail, but we're also wanting to demonstrate those control functions being really in the cloud.
And so why don't you talk a little bit about the secure internet demonstration and how it works?
Sure. So there are two use cases that we'll be demonstrating. One is a secure internet access. Most of us today have internet access that has little or no security, unless you've gone and bought your own gateway, which might be secure, but certainly there are ways to hack around that. Your carrier might be providing a gateway, but we really wanted to focus on security, particularly in this environment where a lot of the funding is going to be to bring internet to places where there's either no service or sorely underserved. And new batch of internet users really knows nothing about security, but I think they have an expectation that those services are secure, and unfortunately that's often not the case. So we wanted to really show how we could bring in the carrier network and even from the cloud a secure service overlay to really your standard internet. And then the second use case is a work from home use case, which likewise we can lay out basically a second network to the home, and then through policy and steering we can bring secure services and control which applications that the customer can reach on this new network based on whatever the policies are for that enterprise that's leveraging the service. This is all in line with kind of a tiered service offering for security. So imagine that you buy your internet service for $50 a month and you're concerned about security, so you want security for my home. So being able to block certain websites, spam filtering, preventing attacks from coming from the internet, maybe that's $5 a month. That doesn't require any in-home device from the carrier at all. So you can cover the entire subscriber base. And then you might have a premium service, which includes not only advanced security, whether it's network security, it might even be physical security, advanced capabilities like parental controls to protect your kids. Then you can bring in a carrier device and maybe you're charging another $10 or $15 a month. So what we wanted to show is this ability to have new revenue generating opportunities that start with your basic internet access, move to kind of your home security, and then further into endpoint security, parental controls, and more advanced capabilities. There's value in the carrier being able to bring in new services to generate new revenues. There's this whole idea of what's the experience. Being able to provide both bandwidth and latency performance where it makes sense really is able to bring that quality of experience that you can't otherwise get by just having a gateway with IP presence in the home, and then your next point of presence is your peering interface, right? So the ability to place IP exactly where it needs to be for bandwidth and latency purposes just becomes of critical value to the carrier, both in delivering new services, but doing it optimally. Because at the end of the day, you have to have a sustainable business, right? So one of the principles we work to, in addition to open, modular, and scalable, is sustainability. Both from an environmental perspective, but just as importantly from a business perspective. And we know that demands on the networks keep going up and the ARPUs don't. So we're trying to enable that second part of the equation.
You kind of alluded to the idea as new services, one of them being smart vehicle, needing the low latency and keeping the traffic relatively local. Obviously, you're not demonstrating anything like that, but do you see that as a driver?
Absolutely, and the smart vehicle, that's an important application. You're going to see many more applications around virtual reality. While I'm no doctor, if your latency is somewhere above 7 milliseconds, you can start to get actually sick by latency in the application. So, the ability to do local switching just becomes it's impossible to really deliver the applications with the quality that's required and demanded without having that IP presence out in the network. So the values go well beyond what we're demonstrating today.
And so from an operator's perspective, the ease of use and the speed of deployment and so forth, how is that impacted by what you're showing?
What we wanted to show is kind of an on-demand aspect. Certainly the next generation, our kids and our grandkids, when that happens, they demand things yesterday, right? I mean, you go to YouTube, you go to Netflix, you go to Hulu, you go to online gaming. They want the same kind of on-demand experience. And, the carriers now, with implementation of disaggregated cloud functions, and certainly in the back office, the maturity in the operations and business support system allows for that kind of on-demand. Now, we've got a simplified on-demand where the end user can go to a simple portal and select a secure internet service. And then if they so choose, whether they have selected the secure internet or not, they can go to selection of an at-home service. So when we do those two services, we're just really exercising the automation that's possible through the CloudCO infrastructure and then its integration with business support systems that lay north there too.
Now we'll hear from Radisys on why they chose to participate in this year's CloudCO demo.
Hello, I am Rajesh Chunduri with the Broadband Access Business Unit at Radisys. Operators globally seek new and innovative ways to build modern access networks with a software-centric approach, be it for the GPON to XGS-PON migration in the wireline, or in the move from 4G to 5G in wireless. A software-centric approach is foundational requirement. for any access network transformation. For many years, Redisys has pioneered open telecom solutions focusing on access networks, both wireline and wireless. To that end, Redisys has actively participated in and led with other like-minded members, both operators and suppliers, in the fixed access network disaggregation and virtualization domain at both the BBF, the Broadband Forum, and the ONF, Open Networking Foundation. BBF's CloudCO with OBBAA, Open Broadband Access Aggregation, and ONF's SIBA with VOLTA, Virtual OLT Hardware Abstraction, are two industry approaches to attain the same goal: a software-defined wireline access network that is enabled by white box hardware built with merchant silicon and powered by cloud native and open source software over open interfaces. Last year, in the Broadband Forum demo at NetworkX 2022, Redisys demonstrated how ONF's Volta-based software-defined white box OLTs can be managed by a BBF's CloudCO-based Access SDN Manager and Controller, along with the CloudCO domain orchestrator. This year, in the BBF demo at NetworkX 2023, Redisys demonstrates our commitment towards the CloudCO architecture with our merchant silicon-based state-of-the-art combo PON white box OLTs managed by a CloudCO-based Access SDN Manager and Controller. Another key activity that I would like to highlight is the BBF's virtual OMCI Plugfest, which again demonstrates a multi-vendor environment with Redisys combo PON OLT interworking with OBBAA's virtual OMCI and ONUs from other suppliers in the community. Redisys offers Connect Open Broadband and Connect Modular Broadband open telecom solutions for the FTTH, PON, or wireline access networks, built with cloud native, open source software, integrated with merchant silicon-based white box hardware, as demonstrated in this video today. We thank the Broadband Forum for allowing us to be part of this pioneering demo, and we look forward to seeing you all at the NetworkX event. Thank you.
So next year, how do vendors or other people get involved in this?
Well, there's absolutely no limit. If you're an application provider, whether you're a service provider, whether you're a traditional telecoms vendor, there's no limitation. If you're interested in the future of broadband and the ecosystem that is driving broadband connectivity and new broadband services, you're welcome. Come and contribute, come and listen, or just sit here with our base events and be educated in the work that we're doing and standardizing the industry.
Excellent. Well, thank you, Craig.
Thank you, Ken. Appreciate it.